Okay, so for this Module 1 quick self-check, I'm going to display the answers quickly, and then I'll come back and I'll explain each one in order so that you can listen to whichever explanations you need. So you can see the answer to number 1 is A and C, 2 is B, 3 is up and to the left, 4 is on the order of 4 times 10 to the minus 10th atoms. You might have gotten a slightly different answer, but it should be on the order of 10 to the minus 10. And then 5 is A, straight up. Okay, so let's go over these and talk about why each one is. So for number 1, which is or are the correct j-hat components? So j-hat, remember, is going to be the same as the vertical, the y-hat directions for the vector c. So the vector c over here, and we want to pick all that apply. So always be on the lookout for these questions that ask to pick all that apply. So we just need to look at the right triangle that has 12 meters as its hypotenuse, and then we have our x component, which would point to the left, and we have our j-hat, our y component, and this is the one that we would like. We notice from the diagram that the angle with the x direction is 25, so that the y component over here would be, in fact, the sine of 25, and it would be negative because it points downward. So that explains the first answer. Also, you can see that because the sine of 25, if this angle over here is 25 degrees, then that means that the angle over here is going to be 65 degrees. And so the cosine of 65 equals the sine of 25. And again, it would be negative because it still points downward. As for the j-hat component for number 2, the j-hat component of vector A plus B, well, we just need to add the y-hat component. So we need to add AY plus BY. AY, it's all in the negative direction, so it would just be negative 8 in the j-hat. And then B has a positive y-hat component, and you can see that it is adjacent to 30 degrees. So I'm going to write that as plus 15 times the cosine of 30 degrees. And when I do that, I get something that is on the order and just about equal to 5 meters. For number 3, what is the approximate direction of vector C plus B? I really just want to add them. So I want to take here vector C, and I want to add it to vector B, as if I had walked along C and then walked along B. I could also do it as walking along B and then walking along C. So I'm going to just sort of roughly sketch those here. I can say that this is vector C, and then I'm going to walk along vector B, and then my final resultant would be something that is on the order of what I have shown here. So basically up and to the left is really what you need. To see if you can see it on the original diagram, then I could have moved it. Here would be vector C. So rewriting vector C, I would then again have something that goes up and to the left. So just remember the head to tail way of adding vectors. Okay, so moving away from vectors, now let's talk about our order of magnitude problems. So this one here, we have a diameter of a hair is about 10 to the minus 4 meters, and a diameter of an atom is about 5 times 10 to the minus 10th meters. About how many atoms are there in one circular cross-sectional area of a hair? So meaning that if I had a piece of hair here like this, then there'd be some cross-sectional area of the piece of hair. And if it was just one atom thick, then how many atoms would be in that cross-sectional area? So we have to do a little bit of calculation here. It's not just how many atoms will fit along a diameter, but instead we have to compare the area. So in order to get this answer, I'm going to erase the answer to start so we have some space to work. And I'm going to say the diameter of a hair is about 10 to the minus 4 meters. So then I'm going to say the hair area, the cross-sectional area of a hair, is then going to be pi r squared. And I'm using the on the order of to remind myself I'm not doing exact calculations. So on the order of pi, and then r squared would be half of this. So pi times 1/2 times 10 to the minus 4th meters quantity squared. And here's where the order of magnitude comes in handy, because I can say, well, pi is around 3, and 1/2 squared is around 1/4, and 3 over 4 is kind of like 1. So I'm going to just round all of those to around 1, and then 10 to the minus 4 squared is 10 to the minus 8th meters squared. So this would be on the order of 10 to the minus 8th meters squared for the area, this cross-sectional area of the hair. Then we need to figure out how many, what's the area per atom. And again, that'll be pi r squared, but it'll be the r of the atom. So that would be on the order of pi times, and then 5/2. So 1/2 times 5 times 10 to the minus 10th. So half of the diameter squared. And again, pi over 2 squared, so pi over 4 is around 1, 5 squared. I'm going to just say this is around 25. So this is why you might have a slightly different answer than 4 times 10 to the minus 10th, but it should all work out to be about the same. So 25 times 10 to the minus 10th squared, so 10 to the minus 20th. And that would be how many meters squared there are per atom. So now I have these two values where I have how much total area I have, and then I have, again, in this cross section, and then I have how much area one atom takes up. So I just have to then divide in order to figure out how many atoms I have. So I have 1 times 10 to the minus 8th divided by, so that'd be how many meters squared per hair. And then I have to say, well, I have 25 times 10 to the minus 20th meters squared per atom. And so that's then going to result in giving me how many atoms I have in one cross-sectional area of hair. So if you remember how to do that, 10 to the minus 8th divided by 10 to the minus 20th, that's going to give me 10 to the 12th. So I end up with 1 over 25 times 10 to the 12th atoms per hair, and that's the hair area, like the cross-sectional part of the hair. And so then 1 over 25, right? So that's basically, going to be 4 over 100, so 4 over 10 to the minus 2. And so that's where I end up with 4, and then 10 to the minus 12 over 10 to the minus 2, 4 times 10 to the 10th. And so that was the final answer that I came up with. And again, you might have something slightly different than that 4, but it's the idea that counts, and it's showing all of that work and your estimates and the approximate or the calculations that go into it that earns you the credit. All right, and then lastly, we have here on number 5, an attractive gravitational force between all objects with mass. And the force is stronger the closer you are to the object. So the net gravitational force is just a sum of all these vectors. So if I'm at point P, oops, that was still on highlight. If I'm at point P, then I'm going to have an attractive force to the right because of the mass that is on the right. I'm going to have an attractive force, a gravitational force to the left because of the mass that's on the left. Those are actually going to cancel out to 0. And then I'm also going to have an attractive force to the mass that's on the top. And so the sum of all of those is simply equal to an arrow that points straight up towards the one at the top. All right, let me know if you have any questions before you take the quiz.